you can have aliphatic amines or aromatic amines. Aliphatic amine you can have primary amine. Primary amine NH2 group oda ஒரே ஒரு alkyl group attached, methyl group or ethyl group or propyl group, ஒரு alkyl group and ஒரு amino group attached இருந்தாக்க அது called primary amine. Secondary amine NH is the group, அதில் வந்து 2 alkyl groups will be attached. Diethyl amine, ரெண்டு ethyl group attached to the nitrogen, ரெண்டு ethyl group attached ஆனாக்க will be only H remaining. These are all derivatives of ammonia. NH3 is the parent compound. ஒரு hydrogen alkyl group replace பண்ணாக்க you get primary amine. ரெண்டு alkyl group அம்மோனியாலேருந்து எடுத்து replace பண்ணாக்க you get secondary amine. மூணு alkyl group replace பண்ணாக்க it's called primary amine, tertiary amine. இதில் வந்து primary amine is also called first degree amine, second degree amine or third degree amine. So example given here, ethylamine, one alkyl group, diethylamine, two alkyl groups, triethylamine, three alkyl groups. Now these are structures of some of the amine. This is ethylamine, CH3, CH2, NH2. This is diethylamine, CH3, CH2 twice. Ethyl group, ரெண்டு ethyl group and NH. இதில் வந்து மூணு ethyl group, CH3, CH2 times 3 N. So as you attach more and more ethyl group, first you will get NH2, then NH, then N. This is called primary amine, this is called secondary amine, this is called tertiary amine. இதே மாதிரி aromatic ring ஓட you can have attachment of amino group. This is called aniline, this is called N-methyl aniline. இந்த NH2 group ஒரு hydrogen எடுத்துட்டு methyl group போடுது. This is NN dimethyl aniline. This is primary amine, this is secondary amine, this is tertiary amine. Now amines are named by naming the alkyl group or the groups attached to the nitrogen followed by the word amines. This is called propyl amine, this is dipropyl, 2-dipropyl amine. Here this is called NN, N, come on, ரெண்டு isopropyl group இருக்கு. It's not propyl group, it's isopropyl group. This two groups இருக்கிறதுனால the di. 2-propyl means it's attached to the nitrogen by the second carbon atom. First carbon atom இருந்தாக்க just we will call it dipropylamine. So இந்த மாதிரி இருந்ததுனாக்க this will be dipropylamine. இது வந்து di2-propylamine because இதில் வந்து second carbon is attached to the nitrogen. இதில் வந்து நைட்ரஜனில் மூணு alkyl group இருக்கு, ethyl group, methyl group and propyl group. This is called ethyl, methyl, propyl. இந்த groups எல்லாம் alphabetical orderல எழுதணும். Ethyl E is the first, methyl second, propyl third, ethyl, methyl, propyl amine. இந்த காம்பவுண்ட் நீங்கள் எழுதலை, இந்த நேம் கொடுத்துருக்கேன் NN3 NN dimethyl amino pentane. So you have a pentane chain. At the 3 position N9 dimethyl amino group is attached. the 3 position, and then only one. This NN means on the nitrogen you have 2 methyl groups, N9 dimethylamino pentane. The dimethylamino group is attached to the 3 position of the pentane. So, this is 3 NN dimethylamino pentane. Aromatic ring la NH group attached pannaga, this is called aniline. This is 4 nitroaniline or paranitroaniline. இது வந்து amino group and methyl group 1,4 position called paratoluidine. The toluene derivative of amine is called toluidine, paratoluidine. This is 1 naphthyl amine, naphthalene, where one group, one position is attached to NH2 group. This is diphenylamine. The NH3 of the ammonia is replaced by 2 phenyl group. This is called diphenylamine. Amines form intermolecular hydrogen bonds, just like hydroxyl groups in phenol, alcohol and carboxylic acid, ketones, etc. These bonds are weaker here in amines compared to alcohols. Hence, amines have lower boiling point than alcohols and carboxylic acid of the same molecular weight. The molecular weight the same irundhanaka, boiling point of amine will be less than that of alcohol. இது வந்து அமோனியாவோட டெரிவேட்டிவ் இருக்கிறதுனால amines are basic in nature, especially the aliphatic amines. Aromatic amines வந்து இந்த amino group வந்து attached to the aromatic ring. The aromatic ring is electron withdrawing. இங்கே resonance structure போட்டிருக்க மாதிரி இந்த double bond, this lone pair goes to the carbon nitrogen bond and this bond moves here to form a negative charge. So, it is becoming dipolar. So, the lone pair of electron is pushed into the ring. The basicity or amino basicity வந்து அதில் இருக்கிற நைட்ரஜனுடைய lone pair எவ்வளோ இருக்குது, எவ்வளோ ஸ்ட்ரெங்க்தாக இருக்குது, அதை பொறுத்து தான் இருக்குது. The greater the strength of the lone pair, the more basic the amino group is. So, basicity of an amine is based on the availability of the lone pair of electrons on the nitrogen atom. Suppose you have RNH2 and ARNH2 and groups attached to the aliphatic chain or aromatic chain decrease the basicity if they are electron withdrawing. This is just opposite to the carboxylic acid. அங்கே electron withdrawing group இருந்தாக்க carboxylic acid acidity will increase. இங்கே வந்து amine basicity will decrease if substituted by electron withdrawing groups. Electron withdrawing group என்ன பண்ணுனாக்க the nitrogen இருக்கிற lone pair, the density will gets reduced. The lone pair தான் வந்து goes and attaches itself to H plus or other positively charged species to form a bond. That is the controlling factor அதனுடைய basicity. Only if electron donating groups are present, the amine will become more basic. The amino group gets into an equilibrium with H plus and OH minus as shown here. RNH2 group H plus add பண்ணாக்க RNH3 plus. So, if the equilibrium is more to this RNH3 plus, we say RNH2 is more basic. If the equilibrium is more to the RNH2 group, this is less basic. The R2NH similarly, the protonate பண்ணாக்க R2NH2 plus, deprotonate பண்ணா R2NH. If the equilibrium is to the protonated form, it is more basic. Tertiary amine R3N, H plus OH minus, similarly if it protonates more, it is more basic. And the variation, the basicity variation, the electron donating group, electron withdrawing groups பார்க்கணும்னாக்க இந்த மாதிரி comparison. This is ethylamine, this is 2-bromoethylamine, this is 2-chloroethylamine, this is 2-fluoroethylamine. நம்ம முன்னாடி ஒரு problem carboxylic acid பார்த்தோம். Various groups are attached to the carboxylic acid, especially the electron withdrawing groups. அங்கே increase பண்ணிது. F fluoroacetic acid is more acidic than acetic acid. இங்கே பார்த்தீங்கன்னாக்கா CH3 CH2 NH2, it doesn't have either electron donating or it's an electron donating group, CH3 group. This is basic. Bromine போட்டாக்க it is electron withdrawing. The lone pair here will go towards the bromine. The lone pair here will go towards the chlorine. The lone pair here will go towards the fluorine. இப்போ இந்த groups எல்லாம் arrange பண்ணாக்க electron withdrawing effect which increases in the order. H is the least electron withdrawing, bromine is slightly more, chlorine is more electron withdrawing, fluorine is the most electron withdrawing. So in the basicity compare பண்ணாக்க aniline is the most basic, parabromoaniline is less basic, parachloroaniline is even less basic, parafluoroaniline is very not basic at all, almost neutral. The same thing happens if you compare aniline to paranitroaniline. Because the NO2 group is electron withdrawing, the lone pair will be going into the ring, and this is very less basic. Now we look at the preparation of primary amines. The first method is called Gabriel synthesis. This is outlined below. The starting material is phthalimide. We have seen how phthalimide is prepared in the unit on carboxylic acid. You take phthalic acid and heat with ammonia, and it first forms phthalimide, then it loses a molecule of water, becomes phthalimide. Phthalimide on treated with KOH, this nitrogen is very acidic because the nitrogen பக்கத்தில் 2 carbonyl group இருக்கு. Carbonyl group are electron withdrawing. The electron withdrawing groups 2 இருக்கிறதுனால the NH group becomes weaker. This can be removed as a proton by potassium hydroxide. So you get phthalimido anion and potassium cation. If you react it with an alkyl halide, this N will attack the R, X will go as X minus, you will get alkyl phthalimide. The alkyl phthalimide hydrolyzed பண்ணாக்க you become RNH2 primary amine plus phthalic acid. You can use either alkaline hydrolysis or acid hydrolysis. Another method, if you reduce nitriles by hydrogen in the presence of nickel catalyst at high temperature, hydrogen adds across Cn. 2 molecules of hydrogen adds across, you get RCH2 NH2. Again, these 2 methods can be used. Primary amine மாத்திரம் பண்ணுறதுக்கு தான் இதை யூஸ் பண்ண முடியும். இந்த cyanide can be easily prepared from ethyl chloride reacting with sodium cyanide, and then you reduce it to form CH3 CH2 NH2. இதில் 2 carbon இருக்கு. Cyanide add பண்ணா 3 carbon, it becomes 3 carbon amine. Here you have CH2. This is called propylamine. அதே மாதிரி benzyl chloride CH2Cl இருந்ததுனாக்க அதை potassium cyanide ஓட react பண்ணாக்க you get phenyl ring CH2CN. இதை reduce பண்ணாக்க you get benzene ring CH2CH2NH2. Phenyl ethylamine, 2-phenyl ethylamine. This is 1, 2, 2-phenyl ethylamine. The above method can be used only for the preparation of primary amines. Secondary and tertiary amines are prepared by reduction of substituted amides இதுதான் substituted amines. CH3 is CH2, CO NH2 is propylamide. This is N-methyl propylamide. This is N-dimethyl propylamide. இது hydrogen and nickel போட்டாக்க you get CH2 NHCH3. இது போட்டாக்க CH2 NCH3 CH3. This is a secondary amine. This is tertiary amine. Reactions of amines. Aliphatic amines with nitrous acid. The nitrous acid is produced by taking sodium nitrite and HCl. Will form HNO2, that is nitrous acid. The nitrous acid primary amine oda react pannaka modalla you get what is called this ethyl diazonium chloride. This N triple bond N plus is called a diazonium group. யூஸ்வலாக இதை கொஞ்சம் வார்ம் பண்ணாலே போகிறோம். இது வந்து அன்ஸ்டேபிள். ஒரு 20 degrees வார்ம் பண்ணாக்க இட் லூஸ் அ மாலிக்யூல் ஆஃப் nitrogen. The water will attack the CH2 group. Nitrogen will come as a gas. You get ethanol. If you have a secondary amine, இந்த N இருக்கிற இடத்துல இந்த H ரிமூவ் பண்ணிவிட்டு NO, N-nitroso dimethylamine. இங்கே வந்து it just dissolves, it doesn't react. This is a trimethyl ammonium nitrite. The aromatic compounds oda nitrous acid react pannaka first amine gets converted to the diazonium chloride, like in the aliphatic amine mari inga aliphatic diazonium chloride, inga aromatic diazonium chloride or phenyl diazonium chloride. The phenyl diazonium chloride is much more stable than alkyl diazonium chloride. இது வந்து ப்ரிப்பேர் பண்ணுறது about 0 to 10 degrees ப்ரிப்பேர் பண்ணணும். இட்ஸ் நாட் வெரி ஸ்டேபிள் தெர்மலி. அதுக்கு மேலே போச்சுனாக்க இந்த மாதிரி ஹைட்ரலைஸ் ஆகிடும். இந்த ஃபினைல் டைசோனியம் குளோரைடு about 0 to 10. அந்த அமீனை பொறுத்து இருக்குது. சில அமீன்லாம் யூ கேன் யூஸ் லிட்டில் ஹையர் டெம்பரேச்சர். மோஸ்ட் ஆஃப் தி அமீன்ஸ் க்ளோஸ் டு 0 degrees. The phenyl diazonium chloride is produced by the following mechanism. This is the nitrous acid, HON double bond O. இதை protonate பண்ணாக்க இது ஆசிட்ல தான் யூஸ் பண்ணுறோம். The hydrogen attaches itself to the oxygen, gets protonated. இந்த bond வந்து moves the water and form NO plus. This is the electrophile. This NO plus is reacting with the lone pair of electron on the NH2. இந்த இங்கே பார்த்தீங்கன்னா இந்த lone pair வந்து இந்த இதில் வருது. இது நியூட்ரல் ஆகிடும். The nitrogen will become positively charged. இந்த H plus will get attached to the O minus. H plus comes to this and then you get this N double bond NOH. இது H plus இங்கே அட்டாக் பண்ணாக்க OH2 plus. இந்த lone pair இங்கே வந்துட்டு இந்த OH2 plus போகிறது. This is the diazonium chloride. So the mechanism of nitrization of second and third degree amine with nitric acid, the nitrous acid, is the same procedure. You get NO plus and with this NH here it will become NOH plus. The H plus will remove, you get NOCH3N. So N-nitroso N-methyl aniline. Now with the tertiary amine phenyl NCH3CH3, the NO plus just adds to the lone pair of nitrogen. You get this compound N-nitroso dimethyl phenyl amine. And if you treat it with this dimethyl aniline with nitroso compound, it attaches, it behaves like an electrophilic substitution. The nitro plus NO plus attaches here and the amine pushes the electron into the benzene ring. The lone pair moves and you get an intermediate for the para attack, just like any Para-nitroaniline formed from aniline and nitric acid, or just any electrophilic substitution, you get 4-nitroso NN dimethylamine. Para-nitroso NN dimethylamine. This should be done near about 0 degrees to 10 degrees, as this NO plus group is very unstable. Now, the diazo compounds that are formed are commercially very important. These diazo compounds, usually in alkaline or acid medium, reacts by coupling with phenols, amines, which are electron donating. If you have aniline ring, you can have the coupling of diazonium compound at this point, the para position. If it is 1-naphthol, usually the coupling is at the para position to the naphthol group. This is the 4 position. If it is 2-naphthol, it will couple at the 1 position. If it is 2-naphthylamine, it will couple at the 1 position. If you have 1-naphthol 4-sulfonic acid, it will couple at the 2 position. ஏன்னா இந்த sulfonic acid group இங்கே 4 பொசிஷனில் இருக்குது, அங்கே போய் கப்பல் பண்ண முடியாது. This particular compound commercially ரொம்ப important coupling component. இது வந்து 1-amino 8-hydroxy naphthalene 3,6-disulfonic acid. This compound is called H acid. Commercially, it is called H acid. இதில் வந்து acid medium யூஸ் பண்ணாக்க இந்த இடத்துல வந்து couple ஆகும். The amino group will direct the coupling to this position, ortho to NH2 group. Alkaline mediumல இது இந்த இடத்துல வரும். You can do 2 diacetylation coupling with 2 different amines or the same amine and use different pH, and you can get both the groups, both the positions, 2 position and 7 position, coupled with N double bond N, azo group. As you increase the azo group in a molecule, the color becomes darker and darker. You will get first yellow, orange, red, green, blue, and finally black, depending upon the number of azo groups. This group is called the azo group, N double bond N. So, aniline couples at the para position. This is para-phenyl azo aniline. This is the structure of the benzene diazonium chloride. You can use it to couple here, here. You can have various other anilines, para-toluidine, orthotoluidine, different groups. The different groups வந்தாக்க கலர் மாத்திரம் இல்லை, இந்த கலரில் different shades வரும். yellowல you can get greenish yellow or slightly reddish yellow, orange plus yellow. So, different colors are produced by substituents in the amines or substituents in the coupling component. So, here I have shown some of the structures that are obtained by coupling. So, if you have sulfonic acid group in the final dye, the compound produced by the azo coupling, the compound in the dissolve ஆகும் water. The water soluble colored compounds are used as dyes. They can dye cotton, wool, and polyamide, the protein type fibers. So, they can use that nylon is a polyamide. So, they can use for dyeing cotton, wool, and nylon. This compound where the azo group is in the first position, phenol group is in the second position, there is no sulfonic acid group. So, this will be insoluble. The insoluble compounds, colored compounds, are used as pigments. இந்த பிக்மெண்ட்ஸுங்கிறது கலர்ட் காம்பவுண்டை நல்லா பவுடர் பண்ணி அதை linseed oil and other chemicals together, that is what you apply on the wall for protection of the wall. So these are used for the pigments. Different colored pigments can be used to produce paints of different color. Next is the carbylamine reaction, where alkyl isocyanide is formed by primary amine reacting with chloroform and potassium hydroxide in alcohol solution. RNH2 becomes RNC. The RNC ங்கிறது this carbylamine is a very bad odor. The other secondary and tertiary amines இந்த மாதிரி reaction வராது. அதனால if you treat the amine with chloroform KOH and you get a very foul smelling compound, that means the original compound is a primary amine. So secondary and tertiary amines will not react and you don't get this carbylamine. The carbylamine எப்படி ஃபார்ம் ஆகுதுனாக்க, the chloroform is reacting with hydroxide ion. இதில் 3 chlorines electron withdrawing இருக்கிறதுனால the hydrogen can be removed as proton. So it HO minus plus H becomes H2O. இங்கே வந்து negative charge. இந்த negative charge வந்து it pushes the chlorine out as negative ion. This will become an electron deficient species. There are only 6 electrons on this. This is called dichlorocarbene. The dichlorocarbene reacts with primary amine. The lone pair வந்து it fills up the empty orbital. Here there are only 3 orbitals. ஒரு ஆர்பிட்டலில் இந்த lone pair இருக்கு, இன்னொரு ஆர்பிட்டலில் இந்த Cl forms a bond, இன்னொரு ஆர்பிட்டலில் Cl forms a bond. This one empty p orbital இந்த lone pair எடுத்துக்கிறது. So it becomes now negatively charged and gets attached to that nitrogen. C minus, and the nitrogenலேருந்து lone pair வந்ததுனால இது வந்து positive charge. So இந்த இது வந்து pulls up a proton from here, it becomes CHCl2. இந்த நைட்ரஜன் இங்கே புஷ் பண்ணாக்க ஒரு chlorine போயிடும். So you get NH double bond C ClH. இன்னொரு lone pair புஷ் பண்ணாக்க it will form N triple bond CH. அதுலேருந்து இந்த OH minusலேருந்து இந்த proton எடுத்தாக்க you will get N plus C minus. This is RNC minus. This is the carbylamine isocyanide.